ফাংশন। তো ফাংশনস যাওয়ার আগে আমার আগের যে ভিডিওতে আমরা বলেছিলাম রিলেশন। সো তোমরা যদি না দেখে থাকো আমার আগের ভিডিওগুলি, তো অবশ্যই আমার প্লেলিস্টে গিয়ে দেখো, আর আমি ডেসক্রিপশনে আমি লিঙ্ক দিয়ে দেবো। আর অবশ্যই এখানে আইট্যাব আসবে, আইট্যাবে তোমরা গিয়ে দেখে নেবে। তো ব্যাপার হচ্ছে যে আমাদের রিলেশন রিলেশন ব্যাপারটা আমরা পড়েছিলাম। সো রিলেশনকে আমরা ধরেছিলাম যে রিলেশনের মধ্যে আর একটা রিলেশন যদি হয় এ অ্যান্ড বি এর মধ্যে, সো আর যদি এরকম কালেকশন থাকতে পারে যে এ বি, ওকে, এসি, এই টাইপের এলিমেন্ট গুলো কালেকশন থাকতেই পারে। তো আমরা দেখেছিলাম। তো এটা জাস্ট রিলেশন বলার উদ্দেশ্য হচ্ছে ফাংশনটা ওয়ান টাইপ অফ রিলেশন, মনে রাখা হচ্ছে। এটা হচ্ছে ব্যাপার যে ফাংশন ইজ এ ওয়ান টাইপ অফ রিলেশন, ওয়ান টাইপ অফ রিলেশন। কি হবে সেটা আমি বলবো তোমাদের। যে here an element A and there are two elements, namely B and C, okay, and this relation are A related with C as well as A related with B. Now it happens only a relation but not function. So দেখা যাক যে what is the definition of function. Okay, what is the definition of function? So at first we know that the definition of a relation, you know that the relation that elements of relation present in the Cartesian plane, namely this A, if we take x-axis in the domain A, right, and y-axis codomain B. So A comma B, A comma B, these elements represent here these points, right, A comma B, and also A comma C here represent this AB plane, right. Now the definition of function. Definition definition. uh, a a function is a a relation between two set, okay, relation or rule that assign that assigns all elements of set A to unique element of a set B. Okay, that's it. Function, that means এটা কি বলতে চাই আমাদের, that function tell us if we take two set A and B, here is set A and here another set is B. If we list the number elements namely A1, A2, that's so on. And this member B1, B2, that's the function is a relation, right? Function is a relation, a special type of relation. Function is a relation. Function is a relation or rule that assigns all member of elements of A to unique element. This is important. Okay, unique element of a set. That means this is an element of A. It relate with these elements, and if A relate with B1, so it cannot relate with any other elements. The definition of functions is called that. So the function generally represented by this type f is a relation, right? If those elements a and b, a comma b, that such that for all a, b and unique b from b, this uniqueness depend on a. Okay, basically function is like a machine, right? Input and output machine. Look, actually, suppose there is a machine, there is a machine which has input and this is output, and this is a if. Suppose these functions actually those elements a and b contain a and b belongs to a such that the specific rule that's b equals to a square, b equals to a square. So if you put 1, then output is this is input and this is output. Input 1, then it's 1 square, right? And that means these elements look like a square type, right? And the function actually it a and this another set b. If you take a b, sorry, numerical 1 and 2, and this is b. These elements map b and 2 map to a by the definition by this function f. Okay, this is a function. This is function because for this one for this one the image is unique. Okay, uh, আমরা পড়েছিলাম what is image of a relation, what is codomain of a relation. That's same thing. Same thing here. Okay. So that one has a unique image that is B, and B also in unique image that is B. So this is a function. Okay, this is a function, but anything one. Okay, so we take two set, another two set, namely 1, 2, 3, and A, E, I, O, U. Okay, if you think one goes to A, two goes to A, and three goes to something else. Okay, this is also function, but if you take this this type, then this A and this B, this and this is not map. This is not mapping. This is not a mapping a function. This is not a function, as there is no image. There is no image of A3. Okay, there is no image of 3 that belongs to A. The this violates the definition of function, right? What is the definition of function? See the definition. All elements, all elements of A set A, all elements. Okay, all elements has a image, and that particular element of A has particular image. Okay, this is not a function, right? You got it? So, so now same thing, uh, same as a real relation. So relation we have read the image range. Okay, domain of the the function. Okay, domain of the function. If f is a function from A to B, be a function. Let g be a function, then A is called A is called domain and codomain of a function. Now, this is another important thing. This is domain, and B is called codomain. B is called codomain. Every element maps an element of B, and this map is actually the definition of a f the function. This okay. Uh, Next term is range. A range is another term, a range of a function. Range of a function. And this term is range is for function, not a relation. Okay. So in a relation, we learn, we read the um, these two terms. Okay, domain and codomain. But a range is new term for function. Uh, it is another another things that f is relation, but uh, the range is specific word for function. So what is the range of a definition? Okay, function of a function. So range is a range. If we take a function f a to b, of course a and b are non-empty sets. That's the definition applicable. So if both are empty, but one of them empty, then uh, you can't find any elements. You can't find elements, right? It does not exist any elements in a phi or on empty sets. So it is non-empty. Okay. So be a function. Okay. Be a function, and the range of f is denoted by is denoted by rf, range of f. Okay. Or okay, another thing. Okay, and this f of a, and that's the definition. The definition, what is the definition? This type. Those elements fx such that x belongs to a, and this is a subset of b. Not it cannot say be equal. It may be equal. Okay, may be equal. Okay, okay. The range, note, a range of a function is a subset of codomain. Codomain. Okay, so this is the actually range. Okay, now one thing, uh, taking an example, right? If okay, I'm taking an example. Uh, if we take a linear function, okay, so real number to real number is defined by is defined by fx equals to 3x plus 1. This is a rule. Okay, this is rule. So these domain and codomain are same, right? So here domain of f equal to r, and that's the okay, and codomain of f also r. Now, if we take n elements, right? Like 2. So what's the image? 2, 3 into 2 by a definition of f. That means 6 plus 4 equals to 10. So input 2 and output is 10 by this f. Okay, by this f. This is a actually example of this. And actually, okay, I'm taking this. 1 minute. Function basically, okay, this is a linear function. This variable, that means x, degree 1, right? Degree 1, that this is polynomial, right? Polynomial function. This is polynomial function. So many type of function. So now many type of functions are there. So at first we told uh, 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 okay, function basically this is a function, right? And what is range? Okay, range. Another example. Okay, example type. Okay, if this discrete set 1, 2, and 3, 2, this actually 2, 3. Okay, this, and by definition is this x equals to 2. Okay, this is name is constant function. This type of function is called constant function. Constant function. So every value of the domain you can the range is singleton set. Then it's called constant function. So here f1 is 2, f2 is 3, 2, and f3 is 2. That means here 1, 2, 3, and this is 2, 3. 1 goes to 2 goes to 3, 2, 3 by definition f. And basically a range of f, or this is written by this f 1, 2, 3. Okay, this is singleton set 2, right? Singleton set 2. That means what is the definition of range? Fx for all x belongs to 1, 2, and 3. This is the domain. Okay, okay. That means only two elements in a range. So it is singleton set. That's why this function is constant. So note that It is an important observation. 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 If any function, any function, if a function, right? If a function has um, range, singleton set, singleton range. Okay, uh, and this type of if a range of any function, range of any function is singleton, then the function, the function is is constant. Okay, now this function, right? If you take another function, that means this type of function. Okay, and the previous example, okay, this 1 2 3 and 2 3, right? So if you take as Cartesian coordinates, x-axis as a set A, that means 1 2 and 3, and B, that means 2 and 3, right? And this 1, this 2, and this 3, these elements are there, and these elements and 2 3. So this 1 from this 2, this this is actually function uh, one type of relation, special type of relations, right? So a relation represent a point relation. Any elements of relation is a point, so represent a point. So function also represent a points. Okay, elements of this, and we know that this type. Okay, if you replace, if we replace B F A, that means singleton set 2, that means this. Okay, this is actually. So okay, if you take okay, a function. Okay, this is another example. You check it, A here and V, and this is a function, right? Any function. Now actually I am going to tell you that what is the actually counting, function counting. Okay, function counting, the number of k counting. So function counting, what is the number of functions between a and b? Okay, this f, this name 1 a1 a2, and this b1 b2, that's it. Now you observe that a1 has this ways. If you take a finite set A, name m elements, this is finite, finite. This is also a finite set. So A1 has A1 has m n type of choice, right? A1 like A maps can map A B1 can C1. So one type unique. So this type of map, right? Okay. So for A1, the choice is n, and A2 choice is n minus 1, right? And another choice this. These choices are distinct, not dependent each other, right? Actually, this is separate. Okay, separate. No, this is dependent, right? A1 choice n time, and then you choose A2 is n minus 1, right? One decrease. So A3 choice n minus 3, and so on. This last term, this is 1, and this actually. Sorry. This type. Okay, okay. The function, if A goes to a B1, right? Then B goes to A1. This is also map. No violence. The definition of F, right? So actually, this N, this also N, this N, this also N, this also N, this also N. So total choice, total N into N into N. How many times? There are M elements. So M times, right? So N power M. That means what is N? The coordinate of B, and M is coordinate of A. So the number is the total number of function A to B is n power m. That means coordinate of B power coordinate of A. This is the actually, okay, and actually this is advanced concept. If you this, okay, and advanced thing. So this type is defined by, and from this we inspired by this, these are defined by this set of all functions from A to this type. Actually এটা আমরা ডিফাইন করি এইভাবেই আমাদের ফাংশন মানে নোটেশনালি এটা ইউজ করা হয়। ওকে, নেক্সট, the important topic is type of, okay, one function. This is very much important. What is one function? One or this is injective. This is injective function. This is injective function. Okay. One function or injective functions. Actually, okay, one function. let f a to b be a function, be a function. Okay, be a function. Okay, let a and b from a any elements such that if a equals to fb, that implies a equal to b, and this then f is called f is called 1 1 1 1 or injective function. Function. Okay, this is it. So example is 1 1 function. So take is linear function fx equals to x. So if define r to r, okay, r to r, real to real. So this is actually straight line passes through origin. This is actually uh, mm, okay. This is actually straight line which is passes through origin. Okay, this is passes through origin. So this is real. This is real. Basically, this is Cartesian product, Cartesian plane. So any elements take a1 and a2 from any two real, they are distinct. Okay, they are distinct such that distinct or not, it is not, I cannot say. So f of a says f of b. So f of a1, right? F1, f of a1 equal to f of a2, and by definition is x to x, right? So this is a1 equals to a2, and we see that this functional value are same. This implies that the points are same, the preimage are same. So note here the new thing. Okay, note here actually note well define of well definedness of a function. What is the well definedness? Okay, if x1 equal to x2, that implies f of x1 equal to f of x2. Do to image two points in a domain, in a domain, if they are same, then these image points are same. Okay, the first point. This is definition of well definedness is second definition. Actually, first definition is if a to b be a function, be a function, and first well defined, the first point of the well definedness, first point, f of x is the element of b for all x belongs to a. The first definition or first point, well defined. The second is this x1 equals to x2. Okay, x1 x2 from a such that x1 equals to x2. That implies f1. This implies if x1 equals to f x2, right? And here these 2 points defines the well-definedness of a function. This note 2. This is actually a mistake. So note 2. Okay, if f of a equals to b, then b is called image of a, and a is called pre-image pre-image of b under under f under f. Okay, this is the highlighter image. This and this is pre-image. A is pre-image and b is called image of a, and a is called pre-image of b. So 1 1 finished. 1 1. Actually, what is the definition of 1 1? So look at the definition of 1 1. So 1 1 is says that if you two uh, two functional points are same, then the preimage are same, right? That's called, this type of function is called 1 1. So next, the counting of 1 1 function. The counting of 1 1 function. Now counting of 1 1 function. Okay, and actually you take if a to b a a 1 1 function, 1 1 function, and suppose the coordinate of a equals to m and coordinate of b equals to n. Actually, this says this is actually a, right, and this is the actually b to 6. There are in points and there is n points, and now this 1 1. So 1 1, that means this. Okay, so single element goes to single element. If you, this is not actually, this is not 1 1, right? This is not 1 1. Why? A1, f of a1, f of um, f of am are same, that is b1. Image points are same, but this not implies a1 equals to a2 m. So this is not equal, right? But they are not equal. So this is not 1 1. If it's not 1 1, not 1 1. So one thing, if you to find sets, okay, this 1 2 and this another sets, and 2 actually this 3 4 5, and this 1 1 function, f is 1 1 function, this f is 1 1 function. So a goes to 3 and 2 goes to 4, this, but this is the 1 1 function. Okay, this is a 1 1 function, this 1 1 function, and this is 1 1 function. Okay, this is 1 1 function, but this is not 1 1. Okay, this is not 1 1. It is actually, this is not a function. So uh, this is not a function. So 1 1 property of a function has a property of function that it is not function. So this is 1 1 cannot, this actually is not happen. Uh, Sorry, 1 1 is the property of function, one type of function, right? So it is not function. So 1 1 not 1 1. So 1 1, that means okay, the definition is clear, right? So now counting is matter. So if you take this, this, so how many? Actually, this is B and this is A. The coordinate of 2 and coordinate of B is 1. So how many 1 1? This is uh, actually function is not created, right? I- The function is created, functions created. Function what, number of functions is what? B 1 power 2 and 1. This is the function. Coordinate of B power A. This is the number of function 1. So how many 1 1 function? But it is not a 1 1. So it is 1 1 function is 0. So number of 1 1 function in this case number of 1 1 function, number of 1 1 is 0. So when the number 1 1 function exists, right? And this type of actually coordinate of A, coordinate of A. So that's type. Actually, uh, okay, okay. If you like this video, then like, comment, and share, and subscribe also. Do subscribe. So now, suppose coordinate of A equals to M, and this is for 1 1, for 1 1 function, for existence of 1 1 function, for existence existence of 1 1 function, existence of 1 1 function, if the condition is M less than equals to N. That means coordinate of domain is less than equals to coordinate of codomain. Okay, so then 1 1 exists. So now the problem is how many 1 1 functions are there, right? So let's the count. Let's okay. If A, okay, this function, this is domain A, this is domain codomain B. Sorry, A1, this is AM, B1, this is BN. Here restrict the condition is this. Then a 1 1 exists. If you the function, right? At first it is function, one function. So it is function, that means all points has a image, right? This is unique image. So this aim 1 1, that means A is in B. A is in B. the copy of B. Copy A, B has a copy of A. Okay, so actually M actually M there are M elements. So number of actually this N. Okay, what I'm saying. Okay, B has a copy of A. If A is if is on, so B has copy of A. B has a copy. B has a copy of A. That means um, that means there are m elements. There is n elements. N elements. Collect m elements. Collect select n elements. Select m elements. Select m elements and permute there. Okay, permute m elements. So this is the actually number of this is the number of one function from A to B. That means this is n factorial by m factorial n minus m factorial into m factorial. This m factorial n factorial cancel out. So the remaining term is m factorial divided by n minus m factorial. This is equals to number of one function. So this actually n p m. This is number of one function. This is a counting. Very easy. ठीक है. So now we take this. Okay, one function. Now another thing is onto function. Onto function. Onto function. And onto function, the another name is another name, onto function or surjective. Surjective map. Map of function. The name is they are similar. The similar name. Same name. Okay, functions or mapping, right? So onto or surjective function. Let okay, okay. Let if a to b be a surjective function, surjective or onto if all uh, image of okay, every every element elements of B, that codomain actually. This is codomain has pre-image has pre-image in A. So in A, pre-image kotha hobe in domain. Actually, function the if we take a function, that means the function is obey the rule of the well definedness. This well definedness one and two. If we say f is function, that means this A satisfied these conditions. This is must satisfy these conditions. Okay, actually this is very important notion. So adjective is a every elements in a V That means this is A, this is A, this is B. Okay, 1, 2, 3, 4, A, B, C. That means this, 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 and actually not. Okay, this is actually D. Then it's 4. This is the all. This is called codomain. Actually, this is codomain. So all elements. Okay, this F, right? This is F. So F inverse 1, sorry. So any elements for all B, this F inverse B exist. And so if you take this type of elements, so inverse image of, then in this case inverse image of 4 is not exist, right? Does not exist, and does not exist any pre-image, right, of 4. So this is not a condition for this. Okay, this is domain of F. Okay, so what is the definition of this? That means the definition is fx, sorry, that means x from A such that fx equal to b. This is the definition. Okay, this is the important definition. So that's it. So inverse image onto that means that note here. Okay, note in a onto function, onto function, every elements onto function every inverse image of inverse image of codomain exist. That means if inverse whole B is a subset of A, okay, subset of A. Basically, this is equal to A. Basically, this is equal to A. But no other elements. So if you take subset, that means if it's a one case, this is proper case. So this is not proper case. So proper case, that means this is F is not function, right? This is there exists a element of A such that Fa not in B. So this is actually this violation of the definition of function. So this is not happen. Yes. So this is actually equal. You know, okay. This is a very important observation. Very important observation. Good. Right. This thing. So now, actually, in case of this knot, this is actually okay. Wait. This is not actually. This is exist image of codomain, not image of elements in codomain. in codomain exist. Codomain exist. Okay, sorry for that. Okay, the number of onto functions. So number of onto functions is very important. Mm, number of onto functions. So number of onto functions. Number of actually counting, right? Onto function. Okay. At first we construct a set that means 1, 2, and this is 1, 2, 3. This A, this V. The coordinate of A 2, coordinate of B is 3, right? So if we 1 map to 1, 2 map to 2, but this is onto map, that means 3. Actually, the image of the pre-image of 3 is not exist here, so it is not a onto function. But onto function, if uh, 3 has pre-image, that means these or these two are, then the violates the definition of actually function definitionটাকে violate করে. Okay, so it cannot happen. Yeah. Okay, it cannot be happen. Okay, now okay, onto function, number of onto functions exist. Number of onto functions, functions from A, the cardinality of n, to B, cardinality of B is n. The two types, right? So if m less than n, m less than n, when these sets have many elements, and the codomain has many elements, so it is onto, it fails to an onto. Okay, so it is 0. If m greater or equals to n, then one no onto is okay. So you can count the onto. So onto is n power m minus nc1 into n minus 1 power m plus dot dot minus 1 power k n c k n minus k power m. Actually, if m greater or equals to n. Note that this is the number of onto function. Okay, the last one is last function, bijection mapping. Bijection function or mapping. Function or mapping. Okay, let if it to be bijection, be bijection if f is 1 1 and onto both. Actually, sometimes it is called, sometime sometime it is called a is correspond 1 1 correspondence 1 1 1 to 1. Okay, 1 to 1 correspondence corresponds to b. এটা কোনো কোনো জায়গায় এটা লেখা থাকতে পারে। ওকে, so number of bijection mapping is very important. So this a, this b, this functions is 1 1, this 1 1. If f is 1 1, then coordinate of a is greater than or equal to coordinate of b, right? Right? If f is onto, so what the actually condition? M, the this domain greater than equals to n. That means, sorry, this is 1 1, so less than this. For existence of 1 1 mapping, this condition, okay, for onto a, this. So in a bijection mapping, in a bijection mapping, in a bijection mapping or or function, the coordinate of a equals to coordinate of b. That means the coordinate of domain, okay. So domain of a, coordinate domain of a, domain of, okay, codomain of f. Okay. So now go for the counting. So number of bijection mapping, bijection mapping from a to b. So আমরা দেখলাম যে coordinate of a and coordinate of b is then actually for bijection mapping coordinate of a equals to coordinate of b, coordinate of b, that is say m, say n. So what is the bijection mapping? What is the bijection mapping? So they are equal. So if you take 1 1, acha, okay. So bijection mapping this a and this b coordinate are same 1 2 n. So A1, A2, cardinal same, element same, it is not element same. So okay, এটা মনে হয় যে element same. Okay, so A1 map to, sorry, A1 map to this map to this. So the choice for 1 is n times. The choice for 1 is n. If you take A goes to A1, then the choice for 2 n minus 1, and same thing for n 1. The total choice is n into n minus 1 into dot 1. That means n factorial. That means n factorial. Okay. So the number of bijection mapping is n factorial. So number of bijection function is n factorial. So this is very important. Now I'm going actually, what is the graphical approach? Actually, graphical method need to check how to check. Okay, examples. Okay, uh, so bijection mapping. The example is the example for bijection mapping. So 1, 2, 3, and 2, 3, 4. Then this. This is a bijection mapping. This is 1, 1 and 1, 2, both. Now, graphical approximation. Acha. Graphical uh, visualization. Actually, I'm taking. Sorry. I'm sorry. Hmm. Acha. Graphical line test. Graphical line test. Graphical line test. 1, 1 function for 1, 1. You know that the function actually a relation. So it represents a point. In this elements represents points, right? If we take any curve, right? Any curve. Okay, Cartesian plane. This is Cartesian plane. So this is x-axis and this is y-axis. Suppose. Now, if you take if just uh, this type of, okay, at first we can talk about the function, right? So this is not vertical test for function. So this is a function test, vertical line test. So function, a curve is function or not, it is checked by vertical line test. Okay. So vertical line test, if you take, this is actual domain, this align domain, and this is align codomain. Basically, one vertical points, this actually domain points. Okay. Now take a vertical lines that cuts the, sorry, this is not vertical. So vertical lines, this is the vertical lines. But here L and the domain, this L and this domain, this is the point. This is point of domain. That means element of domain, right? It's not point. This is actually elements of point, right? Then if it is function, so say A and it cut B, A comma B and A comma C. That means this actually X, this actually Y, and C and B are there element of codomain, and A, M, P, that's the elements. Okay. So for this curve, A maps C and A maps C, B also. So this for this curve, right? This point and this point to cut. So actually this is function. Function represent a point. So in a Cartesian plane. So they see that uh, one elements two image for a function. It is not possible, right? It is not possible. It is it violate the definition of function. So it can't happen, right? So it is not function. Okay, clear? It is not function. This curve. So this curve, this given curve is not function. Is not function. For vertical test, line test, the note is note. Okay, test. The what is this test? Vertical line test. Vertical line test. So vertical line test. What is this? Actually, vertical line test. If we if we set domain and codomain of a function as x axis and y axis respectively, if a given curve a given curve intersect intersect by intersect by a vertical line vertical line at mm, only one point, then this curve is function. Okay, this actually vertical line test. If it this this curve C and this vertical lines intersect only one points, right? Intersects with only one points, right? So this is actually okay. If you take if closed 1 2 2 2 3, okay, this is 1 1, this is function, this is function. So this is 1, this is 2, let this 2 and this 3, and this interval, this closed interval, you know that the closed interval. So closed interval AB, the definition is those all real numbers between this A and B are included. Okay, this type. They actually line, they connected line. So this is a curve, right? This is a curve. This is a curve, right? Okay, this is a curve. But here we notice that the domain is actually this and this, bounded by this and this. So the line is this. If you take the line this, okay, the line this, not happen. This is not possible because the this element 2 is a domain, right? 2 is a domain 2, 2 is an element of domain. So f of 2 also belong to the codomain, right? This is 3 codomain 2 and 3. But here we notice that this image point is 2 comma something outside of the codomain. This is codomain. This is codomain. This is codomain, right? This is domain. This is okay. This is domain of function. So the function, this type of um, actually function elements are there. If you carve it this and this type, okay, this is a curve. This is a function. Okay, this this is a function. Okay, but this is not a function. Okay, and one function, one function. That means this is horizontal line test. Horizontal line test. Horizontal line test. Okay, if you take okay, mm, this this is domain and this codomain, and now a function like this, like this is a function, right? This is function, but this codomain, this codomain, right? This is B. So this is actually horizontal line. Horizontal line. This carve the 2 point of the curve, right? 2 point of the curve. This and this. So this has a preimage, right? Therefore, okay, for this curve, namely A1 and this is A2. But f of a1, that this is actually f of a1 equal to b, right? This height is called b. F of function of this height is called f of a, that means this b. So f of a2, equals to b. They are same, right? B. So f of a1, okay, f of a1 equal to f of a2. This, but they are opposite side the with respect to domain, codomain, right? A1 not equal to a2. They are distinct points a1 and 2. So this function is not 1 1, right? And of curve this type of curve is not 1 1. Okay, this is actually horizontal line test. Horizontal line test. So uh, horizontal line test. If give a given curve, a given CB a given curve, CB a given curve, okay, CB a given curve, and a horizontal line, okay, okay, horizontal line, horizontal line, cut, sorry, intersects only one point, then C is a 1 1 function. Okay, function actually uh, we see actually that vertical line test, horizontal line test actually mm, is a function, one function. C is called one function, and it is function. So this is you must we must check the vertical line test. Okay, for a function, vertical line test for function. Okay, for function, but we assume that function is a function, right? We assume that first. Okay, horizontal line for onto function. Okay, this actually this okay name, this is actually uh, domain, codomain, this codomain. Okay, this is codomain, and domain is this aerial axis. Okay, this whole axis, x-axis is domain, and this type that means 2 comma 5 open interval 2 comma 5, and b is taken as a in 2 comma 5 is a open interval, right? Codomain, right? This is codomain. If you take this, if you take this, if you take a function, that means any curve output the range of range is lies between this, right? So any curve from this, if you curve outside of this, so it is no point from this, right? So now if you cut these points, right? Okay, if you this type of this actually there. So see that one points a1, then this a2, this is a3. Okay, so it is actually one. It is not. Oh, sorry. It is onto because every horizontal line cuts at least one, at least one times, right? At least one times, at least one times the curve, right? Okay. If you take the curve, if you take the curve like this type curve, so there is a horizontal line like here, uh, this horizontal line. So this curve like asymptote, right? Don't touch. Actually, they're not touched or intersect. So this curve is not onto because this is a point, right? B. Okay. So inverse image of B is not exist if the horizontal line cut, then we get an image in a domain, right? So the horizontal line is does not intersect with this curve. See, so inverse image of the preimage of B is not exist. Does not exist any preimage of B. This line, this upper lines, these horizontal lines. So this is actually a horizontal line test for onto, right? So note here, note if C be a curve, assume that it is a function. Okay, after function, then it is that matter of talk about one and one two, right? So C is a curve, be a curve. Okay, assume it is a function, right? And a horizontal line, if a horizontal horizontal line passing through horizontal line um, passing through the codomain, the codomain of f. Okay, horizontal line and intersect intersects the curve at least one at least once, then C is called actually then C the curve then the curve function is onto basically. Okay, so if you to if you take this, right, this x and these two elements, a singleton set, this actually, so any horizontal line passes through this, so every horizontal line passes through there is only one horizontal line if p is okay for constant function. This curve is linear, I mean, parallel to x-axis. Okay, the horizontal line parallel to x-axis. So that means here actually a horizontal line uh, parallel to, yeah, parallel to x-axis. So edit this here also. Okay, horizontal, um, parallel to parallel to x-axis x-axis. Okay, these functions. Okay, okay. Thank you for watching this video and do subscribe, like and comment or share. Okay. Thank you for watching this video. And next video, the I will tell you that the many types of functions. Okay.